You need to turn it on. Okay. Okay. We're ready to the next talk today. It's Holger who's going to talk about reproducible builds. Let's give a round of applause.
Yeah. Okay, thank you. Yeah, so I'll talk about reproducible builds. The work I'm presenting is the work of all these people. So I'm only one, and we're about 50 people in various projects who have worked on this. But first, I would like to know something about you. Who knows about reproducible builds already? Okay, more. Who doesn't? Okay. Who has contributed? No one. Yeah, so this is. So about me, I'm using Debian since more than 20 years. I was a DebConf organizer, and then in 2009 I started with PU parts, which does QA testing, test installation and removal. And then 5 years ago I set up this Jenkins instance, and at the end of 2013 I tried to build packages just twice and compare them. And this has become Reproducible Builds org, and I'm funded to work on this also since 2015. So to repeat this briefly, what the goal of reproducible builds is, basically it's to prove that a binary comes from a given source code. Because free software is nice, we can share it, modify it, review it, pass on, but that's all done with source code and not with binaries. We run binaries, but we need to believe somebody that the binary is coming from the source it's been said to be coming. And we want to prove this. First, we want really to know and not believe somebody who says, yeah, this binary comes from the source. But there's also the problem that the binaries could be made by a malicious actor or a compromised compiler. There's this example in the talk at CCC Congress 3 years ago with a SSHD binary which had a CVE where one comparison was wrong. It was and or and no greater than, and it should be greater just. So the difference was 1 bit in the binary, and that was a local root exploit. So you cannot, even if you review everything, just 1 bit on the wrong place can be really harmful. And the other thing, there was also a paper from the CIA, NSA, I forgot how they would compromise developer kits, and then people would download these SDKs, and then they would produce Trojan software, and that was a design paper by the NSA or CIA. And then two years later, it appeared in the wild. There was Xcode Ghost, which was a Trojan SDK for iOS, which was on some Chinese websites, which were faster accessible for Chinese web developers. So people downloaded it and distributed applications which were backdoored. So this is really happening in the wild. And the way we do it is basically we want to be sure that if you rebuild a package or software, that you get the exact same bits and in all parts, not just the binary, but also documentation and maintainer scripts. Everything should be the same, so you can just compare the hash of two artifacts and then know it's the same. So in Debian, that was 2 major areas we worked on. The order is wrong here, actually. First, we made sure that the build environment of every program can be recreated. And secondly, we made sure that programs can be rebuilt in a deterministic way so that you get the same amount of bits. And when we started in 2013, really, there were 24 packages in the Debian archive which were reproducible. And today it's about 94%. And that is huge progress, but 94% still means that there's 1,300 packages which are not reproducible. And this is also when we rebuild in the same build path. There's also the other issue that we want to be able to rebuild in different locales and different dates and different time zones, that all that anybody should be able to rebuild this. And for the build path, we're working on this to make it possible that we vary the build path, but so far we are at only 80-something% with build path variation. And also, we not only need to get 100% of the packages reproducible, but we also need tools so that users can actually verify that this is true in practice. And work on these tools has not been spent so much time yet, because we're still working on making the packages reproducible. And the 6% is really still a lot. So these are 1/3 of the packages which are unreproducible at the moment, of the key packages. So key packages are in Debian a subset of packages. It's about 5,000 packages. And out of those, there are 300 unreproducible packages. But if you go through the names, there are many important ones which really need to be fixed. So on this slide are only 100 of these 300, so there's still a lot of work to do. Yeah, and this can all be seen on test reproducible builds.org, where we have fancy graphs displaying. This is for Buster. The green packages are the reproducible ones, and the orange one are the unreproducible ones, and the reds fail to build. And there we have also package set, where we have for different languages, like for Java and Rust and whatever, it's Python and Ruby. We have package sets for KDE and GNOME, for the Tails packages, and all of them are about 94-93% reproducible. So all of them have some packages which still cannot be reproduced. And besides, we also, while we test for this reproducibility, we find a lot of issues which are not directly related to our course, but are common QA issues, like packages which produce different results depending on the locale where they are built, which are real bugs sometimes. And we also find a lot of problems with software building with new libraries. These are now some examples we have. So can you read this, or is this too small? Yeah, okay. But basically it's, this is an example where every installation shared the same secret, which is not a good idea. And we found this, filed a bug. We have some main pages where the main page looks differently depending on the locale. So this is also a normal bug. Or such failures are also great. Sometimes the percentage is bigger, but so, and what's happened recently, this is more status update. We had a summit in Berlin in 2016 where over 40 people from 20 projects came. So there was Arch Linux, Coreboot, the BSDs, or FreeBSD and NetBSD, F-Droid, Fedora, SUSE, OpenWRT, Tails. Bazel is a build tool from Google, which Google uses internally to build all their software reproducible. Google does reproducible builds not only for security, but also to save money, save developer time, and thus save money, because they can rebuild their sources faster if they are all the same, if they didn't change anything. And we also made a definition what reproducible builds mean. Build is reproducible if given the same source code, build environment, and build instructions. Any party can recreate bit-by-bit identical copies of all specified artifacts. That means reproducible for us. And of course, we still need to define what's the build environment, what is the source code, and what are the artifacts. But this made it on the web page. as a result of this summit. And we also worked a lot on cross-distro collaboration, and we defined a build info file for RPMs. We had build info files for Debian packages before. They describe the source package, so the checksums of the source package parts, the build environment, and the build artifacts. And we had that for Debian, and now we have the format specified for RPMs. We still need to do this for Lead or for other distributions. Also, in the last year, we increased our test setup. In the beginning, we only tested on AMD 64, then added i386 and ARM HF. And this year, we also got access to 8 Moonshot chassis from HP for ARM 64 testing. And we also want to test the other projects like Lead and FreeBSD, NetBSD. We only build on AMD 64, so we might want to do this on ARM 64 in the future as well. And then since the summit last December, also Bernhard Wiedemann from OpenSUSE is contributing a lot. He set up reproducible builds test on OpenQA from SUSE, where he's building every package twice and testing the results. And he actually contributed lots of patches upstream. We in Debian have filed bugs in the Debian bug tracker and relied on the maintainer to send them upstream while he sends them directly upstream. We have in Debian about more than 500 patches, bugs with patches, with the maintainer that haven't applied our patches yet. So that's still work we can do this year to get to whatever, 95% or something. But it's really now a lot of work. And we have also now many more projects which are doing reproducible builds. Geeks is a distribution like NixOS. They are publishing the results. F-Droid does the same. F-Droid is the app store for Android. Lead and Coreboot also in our tests are mostly reproducible, or Coreboot is 100% and Lead 90-something. But there's also Intoto or Tails and Heads. Heads is another Coreboot payload. And MirageOS, this OCaml-based operating system, they are all reproducible now. And that's really neat, something which wasn't the case a year ago. And now some stuff on the build path, which is mostly what Shimon has worked on recently. And as I said, it's only needed in Debian because we want to enable everybody to rebuild in any path. Some other projects like FreeBSD or Coreboot, they always build in the same path in TMP, so they don't have these issues, basically. I'm not gonna say, do you want to explain this in more detail, Shimon, or maybe later? Okay. So basically the build path is embedded by not only by GCC, but also by Ruby, by Rust, by many other tools. They embed the build path. And Jimin wrote a patch that this build path is not there anymore, or it's relative path. Okay, for the recording, the prefix of the path is stripped out, and then the result is reproducible. But this patch has not been accepted by GCC upstream yet, so we're waiting on the results of this work. Then we've written some tools for testing reproducibility. ReproTest is a tool which builds a package twice, varies the environment in between, and then runs diffoscope on it, our tool to show differences. there has now been some work to support more variations. It's at the moment only being used to test Debian and Arch Linux recently, I think. But this is ongoing work. It would be good if you just try it with your software, your build process. And there's Diffoscope. Diffoscope recursively unpacks archives or images or anything, and then displays the differences in the part of it. So you feed it whatever 2 RPMs, then it looks into the RPM, and there's a PDF inside, and in the PDF there's an image. And if only this image, the timestamp will vary, it will show you this part of the difference really. It has output in plain text HTML since the beginning. Now recently also RST and JSON and Markdown output is supported. There's an online version of it, try-diffoscope.org, where you can just upload 2 files and let it run for you. Diffoscope is also available in Debian, in FreeBSD, in Arch Linux, and Fedora, so you can just install and try it. It's also good if you have a new version of something and want to be sure that only this part has changed, what this should change, then you can run it on 2 different packages or whatever from 2 versions. And there has been some optimizations this year on Diffoscope, mostly on huge files, because it was used to investigate the differences between 2 tails ISOs. So there were lots of speeds optimization and some options to exclude certain things also. And yeah, there's a variant of new file formats supported. And if you have a file format which Diffoscope doesn't understand yet, then it will fall back to a binary comparison. But rather, please also file a bug. We would like to add support for that. So it should support more tools. The future work we have ahead is for Debian first that we need to distribute those build info files so that users can take these build info files and rebuild stuff. At the moment they are stored in the Debian archive but not put somewhere where they can be accessed by non-Debian developers. Stephen Chamberlain now during DebConf may analyze the existing build info files. I think we have 70,000 already. We only store them since the last 8 months. And he found stuff like unclean build environments, like packages were used in the build which do not exist in the Debian archive, or packages were used with versions which are not in the archive. So in future probably also uploads will be checked, the build info files, whether they were built in sane environments. And maybe we'll just store them in a Git repository for now, so that other people can just download that Git repository and rebuild software. For Buster is the next Debian release. We will start to rebuild against the Debian archive. So far our tests were just done that we take a software, build it twice and compare with itself. But in future we want to build it maybe also twice, but compare it against the results in the Debian archive, because that is really what matters. And this is the slide I had at the Debian conference 2 weeks ago, where we didn't have the reproducible build should be in policy requirement yet. So at the conference, we agreed that there's consensus in Debian that we want this now. And it's not, we didn't do that at the conference. We found the consensus online because there's huge support in the project. So that now we changed policy to say this packages should be reproducible, which means for the policy document, it's basically a repeat of our definition. And then it says that packages should, if they are built, they should be bit by bit identically. Can you read this? Shall I read this aloud? Do you care about the exact text? And currently, as it's only a should directive, it's okay if packages are not reproducible, they will be released, it's just a normal bug. And we won't file even bugs about it because it's clear by our testing that they are not reproducible. In the future, so after Buster release, hopefully this will become a must directive. But with these 300 key packages which are unreproducible, I think it will take more than 2 years until we are at 100%. I would be happy to be surprised otherwise, but yeah, and we still need to do work on user interfaces so that users can really meaningful benefit from it. So apt could notify the users, do you really want to install this unreproducible software? There's a prototype patch for it in this bug. And we also need support in S-Build or P-Builders or other build tools so that users can take these build info files and rebuild software direct themselves. And we need tools so that users can trust other people's rebuilds. For test reproducible builds, our web page or web pages, as I said, there's Geeks and F-Droid who build and SUSE who do reproducibility tests in their setup, and they publish JSON files. So we want to take them and put them into our database and then create web pages in one unified look, and where you can see, okay, this software is reproducible in Debian, but it's not reproducible in Arch Linux, and that you then can check why. I hope to get this done this year. So if you want to help, first, if you maintain Debian packages, you can go to these QA pages and check yourself if your software is reproducible, merge these patches we have, or fix toolchain issues. Because there's these 1,300 packages are mostly unreproducible because of some, it's usually the documentation stuff nowadays which makes them unreproducible. So we have this web page, reproducible builds.org, where we try to document common cases and ways to fix them. We have mailing lists. This reproducible builds list is the Debian list. There's another generic list. And we have 2 IRC channels as well, one for Debian and a generic one. Yeah, that's my talk.
Do we have any questions for Holger? I guess not. Well, extra applause for Holger, and thanks for the talk.